Good afternoon, welcome to my laboratory. What I'm going to do here is demonstrate how to use an oscilloscope and a function generator and a frequency counter to read the frequency of a spiky, rough signal that maybe the scope won't read, and you won't be seeing the information that you need to see from the digital scope. Okay, so what we have here is the Akula 3-volt flashlight circuit. And this is the waveform that it's making, live and stable right now. Top trace is the burst oscillation trace, and the bottom trace is the sinusoid, and these are from the same measuring points that Akula used for his demonstration, and the amplitudes are the same and everything's the same. Frequency is even pretty close. That's what we're going to measure. I want to measure the frequency of this sinusoid, which is also going to be the frequency of the pulse bursts. Okay, so how can I do that, and how can I tell if the frequency is actually changing and in what direction it's changing? This, of course, is a triggered shot, so every time the screen flickers like that, it's triggering on a different sample, and then the frequency is all screwed up because of all of the fuzz in there and the fact that the frequency is changing a little bit. Okay, so what we have here, the top trace on the Tektronix oscilloscope here, this is a reference signal coming from the function generator, and there it goes out that wire and up into this wire into the channel 1 here, and we're triggering this oscilloscope on this fixed signal coming from the function generator. And that frequency, I have the function generator's sync output going over to the frequency counter, and that frequency is precisely 304.13 or 14 hertz, right? So there's a hertz. So that's a real slow signal, and I'm measuring it very precisely. Okay, and I could measure it even more precisely than that by slowing down the sample rate. But the main thing is we're measuring 304.1 hertz for this signal up here. Okay, now you see this signal is not the triggered signal, that's the signal that's coming from this circuit. Okay, so now what I do is I take the function generator and I vary the function generator's frequency, which is the triggering frequency, until that bottom waveform stands still and has the same number of peaks and valleys as the top waveform. And when I get it standing still, then I go over here and I take a reading, and that is precisely the frequency of this signal now, because it's standing still with respect to that signal. Now, let me get both of these in the screen here. Now if I do some interesting experimental manipulation, like spreading, if I take off the clip on the core here, if I can do this with one hand. Okay. So now I can push the core together or spread it apart. You can hear it chattering in there. So when I push the core together, you see I get that nice Akula signal there, and the frequency goes up on the down on the oscilloscope, right? If that trace is moving, if the bottom trace is moving to the right, the frequency is going down. If the trace is moving to the left, the frequency is going up. So here what I'm going to do is relax my grip on this thing and then watch both the screens, and I'm actually going to separate the core layers. And I think you can see that the bottom screen does not indicate the changes in frequency as accurately or as quickly as the top screen does, right? Because the bottom screen is triggered on every sample set, and so it displays a nice stable signature. The top screen, though, the text screen, is triggering on the function generator. So I can see when I squeeze and relax this core, I can see the changes in the frequency with respect to my reference frequency that's set on the function generator trace on the top, right? Got that? So here, I guess you can you hear that thing rattling? There's the original mica spacer in there, and that's no other spacer. There's the traces. Now if I tweak the function generator to freeze that bottom trace, there, same number of peaks and valleys. And I can go over here and read 298.2 hertz then is the frequency of this sinusoid and this burst oscillation. Thank you for watching.